Let's explore solving a quadratic inequality. Let's start with a quadratic function. And let's see whether we can use the fact that we have a quadratic function in solving these inequalities. Let's think about the graph. The graph will be either a parabola that opens upwards or one that opens downwards. And we want to see what relationship do we have between the graph and the x-axis. When is the graph above it? When is it below it? And when does it intersect it? Let's think about when it intersects the x-axis. Those points of intersection are the x-intercepts of f and they correspond with the roots of the polynomial ax squared plus bx plus c, the real roots, the real numbers that make this polynomial equal to 0. So when talking about the roots of a quadratic polynomial, we look at the discriminant. Which is b squared minus 4ac. And we remember that that is the radicand in the quadratic formula. Let's see what happens when the discriminant is negative. When the discriminant is negative, the quadratic polynomial has no real roots. The roots are imaginary, non-real numbers. So since it has no real roots, f will have no x-intercepts. Let's see what this says about the graph. There are two possibilities. First is that the parabola opens upwards, which happens whenever a is positive. And the second is when the parabola opens downwards, which happens whenever a is negative. So in this top case, when a is positive and there are no x-intercepts, we see that the x-axis must be below, strictly below the graph. Right? The x-axis will never intersect the parabola since there are no x-intercepts. And in the second case down here, since there are no x-intercepts, the x-axis will never intersect the parabola. Here it must be above. Let me continue it down here. What about when the discriminant is equal to 0? So this tells us that the polynomial, the quadratic polynomial, has one root, and it's a repeated root. So f has a unique x-intercept. Exactly one x-intercept. So let's look at the two cases. The x-axis intersects the parabolas exactly once. So in this top case, it must be right there at the vertex. And in the bottom case, it must be at the vertex as well. Right? Exactly one x-intercept. That'll be the relationship between the graph and the x-axis. And finally, when the discriminant is positive, we know that there are two distinct x-intercepts. So the x-axis must intersect the parabolas twice. For that to happen, the intersection will look like this. Down here, it'll look like this. It must intersect twice. Here are the x-intercepts. So let's do a concrete example.